Thank you for coming out in this chilly evening. For the locals in Chicago, it's probably a nice spring day, but coming from Texas, it looks a lot like winter to me. So thank you for coming out. I want to begin my lecture on the origins of agriculture with grateful acknowledgement of all the pioneering research done by Bob and Linda Braidwood on this subject, and literally setting the stage, making the origins of agriculture studies a kind of cool topic in archaeology. And Professor Braidwood was well known for his hypothesis called the Hilly flanks hypothesis. And he posited ideas such as that farming actually first began in the natural habitat of plants and animals, as opposed to the idea that people took these wild plants to marginal areas and started growing them there. The more research we do on sites now around the Fertile Crescent, we're finding more and more that that is indeed the case, that people were cultivating at a low level the plants in their natural environments. He was really the first archaeologist to use interdisciplinary fieldwork to explore, to explore his ideas about the origins of agriculture. Interdisciplinary archaeology means you bring people who are specialists in plant behavior, animal behavior, pulling together all of the information that you need to understand how early agriculturalists lived in these environments. But what was the catalyst that led populations away from a foraging lifestyle, which turns out wasn't all that bad? You could get along really well with just a minimum amount of work in the week, and you lived in a virtual cafeteria, as opposed to a farming lifestyle where you have a lot of risk. Will the rains come? Will the locusts come and eat all my crops? Do I have to protect the crops, etc.? So what would be the catalyst that would induce people to leave this wonderful Eden-like lifestyle of hunter-gathering to become farmers who labored in their fields? Another early thinker in the origins of agriculture was V. Gordon Childe, and many people were looking for catalysts such as prime movers, the things that might force populations to leave hunter-gathering and start farming. And of course, one of these ideas from the very early stages was that climate change played a major role in this transition. And it is indeed still, if you pick up a textbook on archaeology and you turn to the part in Origins of Agriculture, they will now all talk about the effects of climate change one way or another. The work of Childe was such that he assumed he didn't have the benefit of modern geological studies. He assumed that our current interglacial phase, called the Holocene, climate was dry and unfavorable, causing the plants and animals and people to gather around oases, and then they got to know each other and started farming, as one does. But he never did field work to test this, and of course we know it's quite the opposite. The Ice Ages, or the Pleistocene, were the cold, dry periods, and the Holocene, our current episode, was warm and wet. So it's not his fault. We didn't have the geology then, but he got it wrong anyway. He also introduced the concept of the agricultural revolution. So people would often think of the origins of agriculture as something that happened suddenly. Like on a Tuesday afternoon at 4 o'clock, everybody put down their bows and arrows and started planting crops. But we tend to think of these major social transformations in this kind of linear manner. So people are going along doing what they're doing, and then they gradually evolve or suddenly shift to another type of orientation. So it's very natural to think of these linear time frames of social change, where it's just the way we in Western society think. Not all societies see time and change in that way. So, for example, the lower graph has typical Near Eastern cultural evolution of the Bronze Age, which is moderately complex society, becoming the Iron Age, even more complex, and then people move into the Hellenistic and Roman period, the Empire, the imperial periods, Roman Byzantine, into the Islamic empires, as this sort of long march in a singular direction. But if you study the history and the archaeology, you realize that, hold on, that isn't a smooth process. You have these transitions where nothing happens, or you have depopulation and various breaks in this, what appears to be a smooth line of cultural development. So I want to propose to you a kind of different framework for understanding historical events and cultural evolution, etc., that isn't linear. It's kind of a mind game, a thought game, but it's very helpful for looking at topics like the origins of agriculture in a completely different way. So what if social change isn't linear, but rather it moves in cycles? And this is a theoretical standpoint that is, has a lot of literature behind it, called resilience theory, or the theory of adaptive change. And this is the classic adaptive cycle that's used to express these changes. Now, these cycles have started out being used to explain forest, in ecology, forest succession. You have a fire, and then you have the plants, different plants coming in, and then you have the climax forest, and then another fire, to explain those cycles. But it wasn't long before archaeologists jumped on this idea and said, hey, maybe we can use this to explain culture change as well. Let's see what happens. So it is basically these cycles with the fore loop in gray and the back loop in blue, and they go through these four basic phases. You can jump in anywhere. They have these phases have the unfortunate terminology of mixing capital letters with lowercase letters and Greek letters, which all makes sense in somebody's world, not mine. But you can start on the upper left-hand side, which is the alpha phase, where societies are very loosely structured. You can think of a hunter-gatherer society, loose structure, low connectedness. You can see on the lower x-axis is a graph of connectedness. So it means that people are pretty much free to make their own decisions, to deal with stress in the way that is best for them and their families. And then you move through more and more complex civilization, going on to the fore loop, into the R phase, where you're getting more structure, more connectedness, and into the K phase, which represents complex society, where in a complex society, you have things so interconnected that it's very hard to make a move without getting all the checks and balances and the right stamps, very much like the university system in my mind. And then when this society in its K phase is struck by an outside stress, like climate change or even internal stresses, plagues, and those kinds of disrupting factors, it's very hard for societies in these positions to make quick adaptive changes. So then you go into a release phase in which things sort of fall apart and get restructured in a more loose manner. Some people may refer to this as collapse, but in archaeology we're getting away from this notion of collapse because even in the traditional societies that we think of collapse of the Roman Empire, collapse of the Maya, we still have 5 million Maya speakers. So what is it exactly that collapsed? And the Roman Empire didn't just fall apart and disappear. So there is still the memory of previous culture, the memory of previous technology, and these carry through along the back loop. So as societies are restructuring and more free to organize themselves in different ways, in new ways. Okay, so that's the heavy dose of theory for this talk, but I just want to explain how these looping factors might work in when a society is faced with climate change. So, and this works not only with past societies, but we can also look at it for our own society as well. That's the beauty of these kind of models. So successful strategies in times of deteriorating climate, and for the Near East, that is droughts and bad harvests, etc., people engage in risk minimization for security. So there's diversification of food resources. You may not enjoy eating the barley, but it survives better than wheat. So you mix wheat and barley in your crops. Converting surplus food that you may have into non-perishable goods, food sharing, freedom of mobility to move to another place if things get really bad. The for loop is a really good strategy in times of climatic amelioration. Then you can maximize the risk. This is very much like the financial markets. When you feel secure and there's low risk, then you want to maximize the risk for greater gain, such as cash cropping or buying out a bunch of stock in one company. It's all sort of the same idea. And this is highly connected organization is beneficial, and hoarding of goods is beneficial, all on this for loop when you have a climatic amelioration. When you have climatic deterioration, it's not so good to use these strategies. Okay, so let's examine the evidence for climate change as a catalyst for agricultural origins from this perspective of looping through and returning to old strategies and adopting a few new strategies, connectedness, and more loosely organized societies. So my research has mostly taken place in the southern Levant, primarily in the modern country of Israel, and looking at archaeological sites from the very late hunter-gatherer phases. I look at the types of plants that people are using in these periods. So the Levantine climate today is semi-arid. It's challenging for farmers today, and throughout most of the episodes of farming in these areas, it has been challenging. So it receives, on average, a median right smack in the center of the country. It gets about 600 millimeters of rainfall a year, which is fine when you actually get that, but if it's less, then you have periods of famine and low yields in agriculture. The vegetation of this region through time with climate change has fluctuated over the period of the ice ages, the late Pleistocene, and the vegetation itself goes through adaptive cycles. And these cycles are related to forest expansion in the moisture periods, and the forests are represented by the green blobs on the western side. And in times of dry episodes, you have grassland expansion. And these are primarily driven by climate change until you get into agricultural periods. So, what are these climate changes? I'm talking about climate change in the late Pleistocene and early Holocene. So, brace yourself, we're going to get some climate scientific data here. Okay, so this is it. This is one of our best records from Nahal Zorek Cave. It's an isotope record that has very high resolution data on wet periods and dry periods and cold periods and warm periods. On the left of the graph, you'll see the major phases of what we call the Epipaleolithic. These people are no longer hunting big game animals. They have started intensely going after smaller game, bunny rabbits and that kind of, and small gazelle, etc. Something that upper Paleolithic or earlier Paleolithic people wouldn't even touch. They use a wide variety of different plants at different phases. So the earliest are the Kabaran, and they existed in the last glacial maximum phase, represented here by the yellow colors as a cool, dry episode. It was quite cold and quite dry in the Levant at that time. We have the geometric Kabaran, which nobody knows anything about. We have the stone tools, but we really don't know much about the kinds of plants that these people used, although I'm working on some sites now that will hopefully clarify that. We have, and this is a time period when the ice ages were basically done. The ice was melting, the planet was warming, and the forests were expanding. Life was getting better and better during the geometric Kabaran, during the early Natufian, which followed that, also very warm, very wet. And then you had the late Natufian period. The descendants of the early Natufian people were hit by a cold, dry phase that climatologists estimated began within the space of about 50 years, 50. So it would have been conceivably in somebody's lifetime that they would have witnessed this transformation from a warm, wet climate to a very cold, dry climate. And this phase, the younger Dryas, right there, you will read about in the books on the origins of agriculture as being the prime mover that made people who were suffering from the droughts, etc., and hunting and gathering was no longer profitable. Then they started doing agriculture. You might guess that I don't really agree with this philosophy, but so this period lasted for 1,500 years, 1,500 years, and nobody was a fully fledged agriculturalist in all that time. There was low-level cultivation on and off of wild grasses, even from the Kabaran period. People were, from the very beginning of the Epipaleolithic people, we have evidence that they were opportunistically sowing wild grains and reaping them when they came up, but if they didn't, there were always other things to eat as well. And then, of course, we get into the Neolithic, but we'll deal with that a little later. So the dominant linear model, and probably that might be too light for you to read the writing there, the dominant linear model for the role of climate change leading to the origins of agriculture begin on the left with environmental stress. So the younger Dryas, cold snap led to droughts. Then you move on to decrease in resources, including both the nuts of the forest and the wild cereal grasses. This induced new social and economic solutions. people started cultivating cereals to overcome food shortages. The people who came up with this model, I imagine, had never been farmers. And I am not a farmer myself. My withered tomatoes are a testimony to the lack of farming skills that I have. However, I do know that farming is a risky business, and it's not something you want to begin doing or put your entire economy into when you live in a climate that's unpredictable, full of droughts and frost and uncertainties. So that never quite made sense to me. So I had to come up with my own model. So it's important to examine how foragers actually responded to environmental stress, because we know a lot about modern and pre-modern foragers, but nobody ever thinks of the Natufians, the ancestors of our agricultural beginnings, that they were actually hunter-gatherers like all these other hunter-gatherers, but they were. So we can learn a lot about how real hunter-gatherers in modern times deal with climate change. I won't make you go through this whole graph, but we do know things such as hunter-gatherers alter their resource priorities. So if they may go after the big juicy nuts, and just as an afterthought, some of the cereals, which are harder to process, harder to collect, these little tiny grains, like what are you going to do with those? But when the nuts start going away, those little grains start rising in importance and become the main staple of what these hunter-gatherers start eating. And they start intensively exploiting these little hard-to-get foods, that's plants and animals, and use new technology. Okay, so what does that tell us about ancient foraging strategies and early cereal cultivation? Let's start back again with the Kabarans, the first epi-Paleolithic peoples who lived during that very cold, last glacial maximum period. And we actually know a lot about the plants they used and ate, because we have a wonderful site on the western shore of the Sea of Galilee that was waterlogged for millennia, and then during some severe droughts a number of years ago, maybe 10, 15 years ago, the site was exposed and had amazingly wonderful preservation of plant remains. So everybody was expecting to see that they were perhaps eating a lot of nuts and using a lot of wild cereals primarily. But what we saw there is actually they were using nuts and they were using some wild cereals, wild wheat and wild barley grow in that area, but they were using a phenomenal amount of these tiny seeded grasses, weeds essentially. Imagine going to the weeds in your garden and shaking them to get the tiny seeds that fall out, and that's dinner. So that's what they were doing. So that was kind of surprising. But it shouldn't have really been surprising, because that's what modern hunter-gatherers do when they're under phases of climate stress. So I wanted to fast forward. As I said before, the in-between time period of geometric Kabaran, we don't have good sites with good plant remains. So fast forwarding to the Natufian sites, the hunter-gatherers who lived in the Near East, were ancestors to the first farmers. And so I got samples from a number of sites to look at the plant remains that they might have been using from early Natufians sites, that people who lived during these warmer, wetter periods, and late Natufian sites when you had that overnight snap of cold that lasted more than last night's snap of cold, lasted 1,500 years, and I did exactly what I was warned not to do. Okay, where am I? Okay. Okay, so Natufian foragers were quite fascinating group of people. They had semi-subterranean houses. They made beautiful jewelry out of shells. They had beautiful artwork, and we have burial one fantastic burial of a woman shaman, and you can see that in the lower part of the screen. She was buried with an eagle wing and a number of tortoise shells, and they had a very rich culture, in short. There's the semi-subterranean house. They had grinding stones. They had milling apparatuses and pounding stones. They had a quite sophisticated culture and some of the earliest settled villages, permanently settled villages. Now, direct evidence for plant remains at archaeological sites usually comes from the charcoal, the charred seeds, the charred wood, etc. But for some reason, it is really difficult to find charred remains from most Natufian sites. Just when you want to know what those plants were in the run-up to agriculture, nothing. You don't get any charcoal. However, there is another technique, which happens to be one of my pet methods, called Phytolith Analysis. And phytoliths are microfossils that form from silica. Their composition is opal, like the gemstone, and they form around the cells of a plant, the living tissue. They fossilize that tissue. Then when the plant is brought back to the archaeological site, they're the size of little silt grains, dust, like a grain of dust. And they disintegrate and they get incorporated into the sediment of the site. And then thousands of years later, someone like me comes along and does the analysis of these sediments, and lo and behold, secrets of the past, right there under the microscope. You can see exactly the kinds of plant remains people were using in the past. So phytoliths and starches are often the only evidence for plant use, and phytoliths are abundant at every Natufian site that we've tested to date. So there's lots of interesting things to do. So we have phytoliths from wheat, wild wheat, and we have phytoliths from the woody plants that come from forests, like acorns and the wood itself. And doing the analyses of these phytoliths tells a really interesting story about plant use in Natufian times. So the early Natufian period, when you have the expansion of forests, these are graphs showing the density of these phytoliths in the sediments of the site. You can see on the left side the early Natufian with high peaks of woody plants, but you get into the late Natufian periods and the woody plants drop off. So if the woody plants drop off, what's there? No surprise. You find the phytoliths from grass husks in much more abundance in these late Natufian sites. Okay, so this is following the model of the stressed hunter-gatherers starting to collect cereals and other grasses. So looking at these husks, you wonder, you might think, okay, run up to agriculture. These Natufians are collecting wild wheat and wild barley. But if you look at what's there, you actually, just like the Kabaran period, their ancestors in the Levant, they are using the green bars, which are the wild weed grasses. They are using the wild weed grasses just as much or even more as the wild cereals. So they're just out there collecting everything. They're diversifying, which is what people do in times of risk. And that's what the Natufians apparently are doing. They're not concentrating on the cereals. They're not driving the change from hunting and gathering to cereal agriculture because they're just collecting everything and probably planting everything on a low-level format. Okay, another thing is they're intensely using reeds and rushes that come from the wetlands. So when you live in a semi-arid environment, where do you go when it's really dry? You seek out these wetlands and marshes around springs, and it's like lots of things to eat and lots of materials for building and making baskets, etc. So it's kind of what I call not the agricultural revolution, but the monocot revolution. A monocot is a grass, a reed, or a sedge. Okay, so the phytolith data show that during the early Natufian, forest resources seemed to be more important than grassland resources. During the late Natufian, there was an increase in the use of grass seeds for food, but grass seed use was not restricted to wheat and barley. They were using wild weeds, seeds as well. And there was a general shift from the use of woody plant towards the intensive use of monocots, the grass, seeds, reeds, and rushes. So the economics of the early Natufian household, warmer, moister climate in this bowling Alarod period, could support the sustained use of forests. So the early Natufians were using the forest. Less dense settlement distribution allowed more freedom of movement because some patches had a lot of nuts one year, but other patches had them another year. Very different from the economics of the late Natufian household. During the Younger Dryas, forests declined, grasses expanded. There was an increase in settlement numbers, led to less freedom to exploit the various patches of nuts. So nuts were sort of off the menu for a while. Sedentary households, like at the site of Malaha, needed to maximize sustainability. So there was even more use of these monocots from wetlands for building and fuel. And wetlands formed a kind of one-stop shopping. It was like the Paleolithic Walmart for these people, because you could get a variety of plant resources that could be reutilized continuously throughout the year. You could constantly go to the wetlands. There's always good stuff to eat in the wetlands. So the Natufian foragers compare favorably to what we expect from what we know about modern foragers. Grasses became dominant over woodland resources. We have more territorial markers, burials and other territorial markers appear, greater use of reeds and sedges, greater mobility in the southern part of the Levant. So we can take this circular model. Unfortunately, PowerPoint doesn't have the adaptive cycle model, so I had to use this as a proxy. So we start out with the yellow motif, again representing cold, dry conditions, the green, warm, wet, the Kabaran cold, dry episode, again, expansion of grasslands, forest contracts, a variety of SGGs, which is small grained grasses and cereals, low-level cultivation, use of wetland reeds and sedges, geometric Kabaran, early Natufian, warm, moist. We already talked about all this, expansion of forests, use of nuts, possible focus on large-seeded cereals. So narrowing down, just like the for loop, when I talked about narrowing down to a few really productive resources, or cash crops as we would think of it today. And then the late Natufians basically returning to the ancestral lifestyle of their Kabaran predecessors. So it is a kind of cyclical pattern that allowed the Natufians to maintain a hunter-gatherer lifestyle by dredging up the memories of what their ancestors did and those successful strategies. So this whole cycle can be seen as a sustainable, successful, resilient strategy for dealing with the periods of wet phases, periods of dry phases in the southern Levant. So it is an extremely adaptable system put together. So if that's the case, then why did anybody ever turn to agriculture at all? Why aren't we still hunter-gatherers going through these cycles? So back to this sciencey graph again. We'll look at the late Natufian, the first phase of the Neolithic, which is the pre-pottery Neolithic, which is the first green line there, a period when the warmer, wetter conditions start. And then the later phase of the Neolithic, the pre-pottery Neolithic B, where you have the warmest, wettest period of the entire last 12,000 years. So the entire Holocene is the warmest, wettest period. And no surprise, that's when you get fully fledged, fully dedicated farming villages, is only in the pre-pottery Neolithic B. So I'll run through these data quickly. I have samples from, although a lot of the Neolithic activity was enhanced in Anatolia and the northern part of the Fertile Crescent, my research is again on the southern Levant. So I have samples that I examined from the site of Dryas in east of the Jordan River in Jordan, modern-day Jordan, and Netif Hagdud, a pre-pottery Neolithic A site in the west of the Jordan River in modern-day Israel. And the phytoliths from Netif Hagdud and also from Dryas show us that people were exploiting lots and lots of grasses, but they're wild grasses, wild barley, wild oats, and they are not cultivating them, they're collecting them. And you can see that previous graph of the husk and the stem that seemed really high peaks of in Malaha on the left actually looks dwarfed compared to the numbers of grass husks and seeds that were being used in the Neolithic period, the part of the graph on the right at Nahal, I said Nahal Chilazon, it's actually Netif Hagdud and Dryas. So back to the resilience model, transformation from foraging to farming in the late Natufian, which equaled the ancestral Kabaran strategies, moving into the pre-pottery Neolithic A, where it becomes warm and moist again, the forest expands, or would have expanded if it wasn't inhibited by human land use and burning of forests. There's a focus on large seeded wild cereals, narrowing down again to cash crops, as it were. But there's a difference here, and that is we have increases in population size. So suddenly the populations are growing during the pre-pottery Neolithic A. But the subsistence strategy is still very similar to their old ancestors, the early Natufian. But then something else happens. During the pre-pottery Neolithic B, the warmest, wettest period in the Holocene, there is the push, more push from increasing population and decreasing home territories. There's the pull now of predictable rainfall, abundant sources of water, springs and streams. Nature is out there saying, hey guys, come hither. I'll make it good for you if you want to do agriculture. And this is when there's almost a complete investment in agricultural economies. Now this makes sense if you're a farmer, because you are now faced with less risk, greater productivity, and ways to intensify production in a smaller and smaller home range. So bring it back to this resilience theory model, the adaptive cycle. Would look like that. So did climate change lead to Neolithic farming? So we know that climate change can have a profound impact on human societies, but the adaptation is unique to each situation. You can't come along and say, it got dry, everybody died, or it got dry, they became this or that. There was some change. Each situation is different and unique. For the Kabarans and late Natufians, their one answer to dry climate was the monocot revolution, the small grain grasses, the low-level cultivation, and sustainable wetland exploitation. This allowed continuity of a forager culture that lasted for 1,500 years from the beginning of the Younger Dryas, from the beginning of the late Natufians. They were able to maintain themselves as foragers all that time after the onset of the Younger Dryas. Agriculture is a high-risk endeavor, and therefore we should expect it to originate under favorable climatic conditions rather than under adverse conditions. The shift from foraging to cultivation therefore requires both push and pull factors, and you need to outline what these might be from both natural and social conditions. Thank you very much.